Hello students, in today's class we are going to learn about stock notation. Many metals show variable oxidation states. Variable oxidation state in the sense like a metal if it is present in two different oxidation state. I am having one example here, Fe plus 2, right, and similarly we are having Fe plus 3. So the same element, that is iron, sometimes it is existing as water plus 2 and sometimes it is existing as water plus 3. Fine students. So these are the variable oxidation states in their compounds, right, and these are specified by Roman numerals. This we have to remember, okay, such as Roman number 1 if it is having plus 1 oxidation state. If it is having plus 2, then we have to write Roman number 2, and if it is having plus 3 oxidation state, then we have to write Roman number 3, and similarly so on, right. And this representation of oxidation number in terms of Roman numerals should be written within the parenthesis. Parenthesis means that is within the bracket we have to write only after the name of the element we have to write. This we have to understand. And this system was introduced for the first time by the German scientist known as Alfred Stock. Let us now try to understand how to write the Stock notation and with a similar typical example. So the first one I will be taking with respect to Cu2O, right, and we have learnt in our previous classes that oxidation number of all the atoms in a molecule of a compound, that is algebraic sum of all the oxidation number of all the atoms in a compound, is equal to 0. So therefore I can write here this is equal to 0. Fine. And we know that oxidation is present in oxidation number of oxygen is present in -2, and if it is -2, then copper will become now +1, right. And if you now calculate, so +1 into 2, that becomes what? +2. Again I will write here plus, and -2 of oxygen will become as what? -2, and this is equal to what? 0. Fine. So therefore now the chemical name of this compound is cuprous oxide. CuProus, cuprous oxide, right. Fine. So all we have to now write the Stock notation. How do we write? First we write the name of the metal, that is what? Copper, COPPER, and we already know that oxidation number of copper in this Cu2O is +1, so that we have to write in the Roman number, that is Roman number 1 should be written within the parenthesis, then followed by the term called as what? Oxide. Is it clear, students? Now let us have one more example, and that example is CuO, right, and we know that oxygen is -2, then obviously copper will be what? +2, and that will be what? Equal to 0. Now we found that oxidation number of copper in this CuO is +2. Fine. Under this case what we have to write here is the name of the chemical name of this compound, that is cupric oxide. Fine. So here we have to learn some technical terminologies, that is if the copper is present in a +1 oxidation state, the name of the compound will be ending with OUS, right, and if the copper is present in higher oxidation state, that is what? +2, then it will be ending with what? IC, that is cupric oxide. Fine. And now all we have to write is here copper, then within the parenthesis we have to write a Roman number 2 and then followed by oxide. Concept is clear, students? In the third example, I will be taking with respect to FeO. And we now know oxygen is -2, then this iron becomes what? +2, because we know that the algebraic sum of all the oxidation number of all the atom in a molecule is equal to 0. Right? Now iron is present in +2 oxidation state, so therefore the name should end with OUS, because we know that iron is present in two different oxidation state, that is +2 and that of water +3. So here there is +2, so the name ending becomes what? OUS. And the stock notation is that iron then followed by Roman number 2 should be written in the parenthesis, then followed by oxide. Similarly, let us take one more example, that is Fe2 then followed by O3, right? And oxygen is -2 and iron will be here as what? +3. Why it is so? +3 into 2, that becomes what? +6. Then plus -2 into 3, that becomes what? -6, and that will be equal to 0. Fine. And now we know that iron is present in +3 oxidation state, so therefore we have to write here ferric then followed by oxide, because it is present in +3 oxidation state, higher oxidation state. So higher oxidation state always end with IC, lower oxidation state always end with OUS, and the stock notation becomes iron then followed by Roman number 3 within the parenthesis, then followed by the term called as oxide. Let us have another example, that will be example number as 5. Let me take it as SnCl2. Fine. Under this case, we know that halogen is present as -1, then this tin will be present in +2 oxidation state, because we know that +2 then -1 into 2, that will be what? -2, and it will be equal to what? 0. Fine. And Sn stands for what? The element tin, that is with respect to the name called as what? Stannum. But here tin is present in +2 oxidation state, so therefore the name becomes stannous. STANNOUS, stannous chloride, CHLORIDE. But in the stock notation we have to write the name of that metal, that is what? Tin, with Roman number 2, that is oxidation state, then followed by the term called as chloride, CHLORIDE. Fine. And in the sixth example, I'll be taking with respect to SnCl4. And we now know that chlorine is present in -1 oxidation state, and here our tin will be present in a +4 oxidation state. Fine, because we know that +4 then plus -1 into 4, that becomes what? -4, and that will be equal to 0. Fine. So tin is present in higher oxidation state of what? +4 here, so therefore the name becomes a stannic chloride, STANNIC, stannic chloride, CHLORIDE, and the stock notation becomes tin with oxidation state, that is what? 4, which we have to write in Roman number within the parenthesis, then followed by the term called as chloride. Fine. Now let us try to understand what is the significance of this stock notation. Fine. So I am having that example 5. In example 5 we have seen that tin Sn is present in water +2 oxidation state. In the course of chemical reaction, if tin is undergoing a change in oxidation state from Sn+2 to Sn+4, what does this indicate? That is increase in oxidation number. Tin is changing its oxidation number from +2 to +4. It indicates that there is a loss of water, 2 electron, and this process is nothing but called as what? Oxidation. We can judge that tin from +2 to +4, if it is changing, the metal tin has underwent what? Oxidation. So stock notation help us to understand that whether the metal has underwent oxidation or that of what? Reduction. In a similar process, if the tin from Sn+4, if it is undergoing change into what? Sn+2, it means that that process is called as what? Reduction. And we know that reduction is with respect to what? Gain of electron. Reduction is with respect to what? Gain of what? Electron. Thus we can conclude that in a chemical reaction, if Sn+4 is undergoing change into what? Sn+2, it means that tin has underwent what? Reduction. So therefore stock notations are very useful to understand whether the metal element has underwent oxidation or the metal element has underwent what? Reduction. And students, in all of these examples, that is from 1 to that of 6, you can see that in all of these examples the metals are present. It means that stock notation is normally restricted to the compounds of metals only, right? Sometimes students say that, sir, what if at all if tin is carrying what? -1 oxidation state, at that time what we have to write? No, metals are always present in what? Plus oxidation state, that is they have the tendency to lose a electron, right? And from higher oxidation state it will be converted into what? Lower oxidation state, but never what? They'll be having what? Negative oxidation state. This we have to remember. Fine. So that was the importance of what? Stock notation. Thank you for watching the video, students. Hope you like the video and kindly subscribe to my channel.